Today we're going to talk about the domain, range, and end behavior of absolute value graphs and absolute value functions. Before we do that, let's kind of recap some terms that you may know from Algebra 1. So we have the first one, relation. What a relation is, it's a set of inputs maps to a set of outputs. So in normal people words, that's just, okay, we input something and we get an output. You go to a vending machine, you hit a button, that's your input, and the output is a snack or the drink or whatever you selected. So that's relation. You have some inputs and you have some outputs, and they're related to each other. This input gives you this output always. Now, a function, that's a special type of relation. It's a relation where each input has exactly one output. So thinking of the vending machine example that I just talked about, if you push the button for Coke and you got Coke and water, okay, that mapping is not a function because you have one input and you got two things back. You press the button once and you got Coke and water back. Now, the reverse is allowed. So what do I mean by that? Well, you could have two inputs have the same output. You see that on vending machines all the time. The popular drinks like Coke and Pepsi, there's 3 or 4 buttons that give you that. So you have one button that gives you a Coke, and then the second button gives you a Coke. That's okay. You can have two different inputs have the same output, like that vending machine, but you can't have one input having two different outputs. So your domain, that's what your input values are. Okay. And we typically think of those as our x values, like we talked about the other day. And your range, that is your output, or the y values. So if we look at our functions here, our relations, we got to determine if they are a function, and then list the domain, domain and range. So to determine if this is a function, I'm looking at my x values and seeing if we have a repeat. We do not have any repeats, so this is a function. And your domain is going to be a list of your x values. So make that squiggly looking bracket to start our list. -4, 5, 11, and 20. That is our domain. Our range is going to be these y values. Squiggly. And I like to go from smallest to largest. Our smallest y value is 2. And yes, it is listed twice. We only need to write it down once. And then the next one is 3. And yes, we also have 2 3s, but again, we only need to write it down once. So this is a function, even though we have some repeated y values or repeated values in the range, because we are allowed to do that. We could not have repeated x values. You could think about it as, all right, if I hit the -4 button, I get Coke. If I hit the 11th button, I get Coke as well. That's okay. If I hit the 5th button, maybe I get Mountain Dew. And I hit the 20th button, I also get Mountain Dew. That's okay as well. This one, I'm looking at my ordered pair, which you remember x comma y. None of these are repeated. None of my x values are repeated, so this is a function. And my domain is -4, 0, and 4. And my range, so the y values, the smallest y value I have is 1. And we have it repeated, that's okay. Only going to write down once, and then 2 is our other y value. Now, this mapping diagram says that 3 is related to 4, so if I press 3, I get a -4. If I press 2, I get -4 and 5. That's not okay. I'm hitting one button. I'm hitting this button on the pop machine, and I'm getting 2 different pops. So this is not a function, but it still has a domain. Your domain is going to be 1, 2, 3, and your range is -4 and 5. Now, from a graph, we have some things to consider. Let's look at this closely. This is an endpoint, so that means the function stops right there, but includes that endpoint. This open circle means that the function or this graph gets really, really close to that point, but doesn't actually get there. So the point, 3, -1 is not a point on this graph. So that means when we talk about the domain and range, we can't include that point. We can't talk about 3, 1 because we don't actually reach it. We get very close though. So what we do is we look at the smallest x value. So right here, the smallest x value is 1, 2, 3, is -4. And the largest x value is 1, 2, 3. Now, you'll notice that I put a bracket around one and a parenthesis around the other. The bracket means value is included. The parenthesis means the value is excluded. This is saying that the domain starts at -4 and goes all the way to 3, but 3 is not included. 3 is not in the domain. We call this interval notation. Instead of writing out all the numbers, -4, -3.999, like repeated, -3, because there's infinitely many numbers across this graph, and it would take forever to write them all out. So we write it in this interval notation, and that interval notation says every number from -4 to +3 is in the domain except for +3 because we had that open circle. The range, we look at the y values. The smallest y value is right here at -1, and the largest y value is all the way up here at 1, 2, 3, 4, 5. Now that -1 is at this open circle here, so we put a parenthesis, and we put a bracket around the 5 because it came from that included point. In letter B, we don't have an open circle, but we have a starting point, and then we have an arrow. That means that this goes off forever. So we're going to have to extrapolate or think about where we approach. Where does this line keep going to? For our domain, the smallest x value is 1, 2, -3. And since we don't have an open circle there, it is included. Now, the largest x value, if we keep following this, that graph's going to go all the way towards positive infinity. So we write it like that, infinity with a parenthesis, because you can't actually equal infinity. Infinity keeps going on forever, so we always put a parenthesis with infinity. For the range, our smallest y value is positive 1. And again, if we follow this up, the y values are getting higher and higher. So eventually we will also get to positive infinity. And that will, again, have a parenthesis. Letter C. There's no starting point here. Okay, so let's look at the left side. You see the left side of this, there's an arrow going down, but the arrow is also going to the left. Yes, this arrow or this function is going down faster than it is going left. It's steeper. That doesn't mean, though, that the function stops moving to the left. It's just not going as fast. So if we were to follow this forever, the x values would eventually get to negative infinity. We look at the other side. Again, our function is going down, but it's also moving to the right. It is eventually going to get to positive infinity. Now, for the range. The y values, since both sides of this graph are going down, the smallest y value will be negative infinity. The y values are going to keep getting smaller and smaller. So we always put the smallest value first. Now, the largest y value occurs right here. It occurs right here at 3. With a bracket around the 3 because we are defined there. We have a point on that. So it can be a little tricky writing domain and range from graphs because you have to determine if you have any open circles like we had in letter A, where the point is not included in the domain and range. And then if you have arrows, you have to really extrapolate and think, okay, the x values are getting larger and going towards infinity, but what are the y values doing too? Are they getting larger or are they getting smaller? So it will take a little bit of practice to get that down. Now let's talk about something called end behavior. And end behavior is exactly how it sounds. It's how a graph or a function behaves at the right end and the left end. So if we are talking about the right end of a graph, the x values on the right side of a coordinate plane go towards positive infinity. So if we're looking to the right end or the right side of the graph, x approaches positive infinity. And if we're looking at the left end, the x values in the coordinate plane go towards negative infinity. So if we're looking at the left side of a function or the left end behavior, x is going towards negative infinity. Now these functions that we're going to talk about always have a right end behavior and a left end behavior. And the way we write that is with this right here. This part right here, as x approaches positive infinity, this means the right side of the graph. And as x approaches negative infinity, that means the left side. And then we have to determine, does the left side go up or go down? And does the right side go up or down? So if we're talking about a linear function here with a positive slope, I'm just going to draw one to give us an idea. Okay. Here's a linear function with a positive slope. Look at the right side. The right side, as the x values get larger, the y values are going up. So instead of saying that the y values are going up, we say the y value approaches positive infinity. Now, you don't have to put a positive sign. It's implied, but you can if you want. So if we want to say goes up, we write y approaches infinity. Look at the left side of this line, we're going down. So when x goes towards negative infinity, the y values are going towards negative infinity as well. goes down. Anytime we want to write that the y values go down, we say y approaches negative infinity. So what I tell students to do a lot of the time is to look at the graph and say, all right, what does the right side do? Does it go up or down? And then write the symbols for it, the math speak, and then do the same thing for the left side. So let's look at a line with a negative slope. Again, I'm going to draw a line with a negative slope going down. And remember this part here, as x approaches positive infinity, that means the right side or right end. The right end of this graph is going down. So to say that it goes down, we say y approaches negative infinity. This means goes down. Goes down. Then the left side, you need to remember this means left side. The left side is going up. So we say y approaches positive infinity. That means goes up. And this will always be true for any function we talk about when it comes to end behavior. If the y values go up, we write this. The y values go down, we write that. And the left and right side are always written the same way. Now, what you may have noticed about the absolute value functions is that those ends go in the same direction. If you have a v, you have the v pointed, or v is opened upwards, or the v is opened downwards. If our absolute value function is opened upwards, it will look like this. And you can see that the left and right side are both going up. You know, the right side here goes up. Well, how do we say goes up? Y approaches positive infinity. The left side is also going up. So how do you say go up? Y approaches positive infinity. So you see that with the absolute value graph, the left and right end both go up when we open up. They both go towards positive infinity. If the absolute value graph opens down, okay, the right side is going down, and again we write that y approaches negative infinity. The left side is also going down. Y approaches negative infinity. So you can see with an absolute value graph, your ends are going to go in the same direction. Either both ends are going to go up, or both ends are going to go down. Or y approaches negative infinity, and y approaches negative infinity. So let's graph this. So a little bit of review from yesterday. We're going to graph this. We're going to do the transformations, and then we're going to go and talk about domain, range, and end behavior. The transformations, that's always R, S, T. We have a negative sign, so we do have a reflection over the x-axis. 4/3 is in front. 4 over 3 is bigger than 1, so we have a vertical stretch. And then that -1 on the inside means we're going to go right 1. And this +4 means we're going to go up 4. So I'm going to plot that vertex. And then down 4, 1, 2, 3, 4. 1, 2, and left 3. 1, 2, 3, 4, and right 3. So that's how our graph will look. I always like to draw my graph before doing domain, range, and end behavior. That way I can look at my drawing and be sure. The domain for absolute value functions will always be negative infinity, comma, infinity. Look at my arrows. They keep going forever, left and right. Now the range. Because our absolute value function is open downwards, the smallest y value is going to be negative infinity. Both sides, the arrows are going down to negative infinity. The largest y value is right here at positive 4. And then we put a bracket around it because it's included. Now for the end behavior. As x approaches negative infinity, that means the left side. And as x approaches positive infinity, that means the right side. The left and right side are both going down, like I've said before. So that means y approaches negative infinity on both sides. So the end behavior is the same. So on the next page here, I want you to pause the video and try these. And once you've tried them, unpause it so you can check your answers with mine. All right, so here are the answers. So go ahead and check it. Check your answers for these two problems. So pause it if you need to look it over. Now the last thing that we're going to do is learn how to graph these with your graphing calculator. Here's my graphing calculator. And the directions are also written up here on how to get to the graphing calculator, and also some helpful hints on how to adjust your window. So what we're going to do is we're going to press y equals, and we see our graphing screen, and we're going to type this in. Oh, negative. And then to type the 1/2, there's two ways. You could type just 1 divided by 2, or on most calculators, if you press alpha and y equals, you see this n over d, numerator over denominator, so 1 over 2. Make sure you press the right button. And then to get the absolute value bars, press math, go over to NUM, and see the first one is absolute value. There is another way to get there. Let's see if there we go. Yeah, if we press the alpha key and the window button, it says abs. Whoops, we want to move our cursor over here. And then we can press X plus 4, then move out of the absolute value, -9. And the reason why I like using the fraction instead of 1 divided by 2, well, it looks like my negative sign went away, is when I'm using a calculator, I always want to make my calculator screen look exactly like the problem. That way the calculator will do the things as I intended. And then we press graph. So a graph looks like that. And like I said, your domain for absolute value is always negative infinity, comma infinity. Our range, the largest y value is at our vertex here, and that's at -9. So the domain, negative infinity, comma infinity, and your range, -9. I'm sorry, negative infinity, because that's the smallest number, comma -9. And then the end behavior, as x approaches negative infinity, y approaches negative infinity, because the left side is going down. Both sides are going down here. And you could have also gotten that because of the negative sign. So hopefully you're getting the hang of domain, range, and end behavior. Those are terms and ideas that will come up a lot. So you really need to get into the habit of knowing how to write end behavior and what to look for. So thanks for watching. Make sure to like this video and subscribe.